In today's video, we're going to cover order of operations. By operations, we're talking about the operations you do in math, which include addition and subtraction, multiplication and division, as well as parentheses and exponents. To help you memorize the order of operations, there's an acronym called PEMDAS. Each letter represents an operation or parentheses, and it's written generally in the order that we want to do the operations. So the P stands for parentheses, the E is exponents, M would be multiplication, the D is division, A is addition, and S is subtraction. So when you have a problem with multiple operations, this helps you memorize which one you should do first. One thing to know is that multiplication and division are kind of equal with each other, meaning if you had multiplication and division, you would just go left to right. So if division came first, you would do that before the multiplication. Same with addition and subtraction. They're kind of equals as well. You want to go left to right, as long as there's no parentheses or anything else that would change the order. And we'll see some examples of that in just a moment. I do want to point out, for the exponent, I put a little 2 here as if it was squared, but this is true for any exponent. I just use this as a placeholder. For our first example, let's say we have something simple like 7 plus 6 minus 3. Pretty straightforward, and you probably didn't need to know PEMDAS to solve this. But let's go ahead and work through this. The only operations we have are addition and subtraction, so we want to go left to right. 7 plus 6, that would equal 13, and then minus the 3, and we get 10. Now let's do the same problem, but with the operations reversed. So if we had 7 minus 6 plus 3, remember I said a moment ago that even though addition comes before subtraction in PEMDAS, they are essentially equal, and so we just want to go left to right. We don't have parentheses or anything else that would change the order. So first we'll do 7 minus 6. Of course, that's just 1. We still have plus 3, and that gives us 4. Here's a similar example using multiplication and division. Say we have 6 times 2 divided by 4. Our only operations are multiplication and division right here. They are essentially equal, so we'll go left to right. 6 times 2 gives us 12, and then we divide by 4. And we get 3. Let's now reverse those operations. So we have 6 divided by 2 times 4. Just like with addition and subtraction, because multiplication and division are equivalent, we'll go left to right. 6 divided by 2 is 3 times the 4, and we have 12. Now let's look at a problem with several operations. Let's say we have 12 minus 8 divided by 2 squared plus 10. It's starting to look a little complicated, but as long as we follow our formula with PEMDAS, we should be just fine. P, standing for parentheses, would be the first thing we look for, which we do not have, but we do have an exponent right here with 2 squared. So we want to take care of that first. And I suggest doing one operation at a time, just to keep everything simple. So the 12 is still there. We still have the minus 8 divided by 2 squared is, of course, 4, and then plus 10. Looking at the remaining operations, we have subtraction, division, and addition. And we know looking at the order, multiplication and division must come before addition and subtraction, when again there's no parentheses, which means we'll want to do the 8 divided by 4 here. So we have 12 minus 8 divided by 4 is 2 plus 10. Like before, we know addition and subtraction are equal, so we'll go left to right. 12 minus 2 equals 10, plus the other 10 gives us 20. Let's do the same problem, but this time we're going to include some parentheses and see how it changes the order and therefore the final result. This time we'll put parentheses around the 12 minus 8. Everything else will look the same, divided by 2 squared plus 10. Since we have parentheses, we'll need to do that first because P, standing for parentheses, is the first letter in PEMDAS. So 12 minus 8 gives us 4. We still have division and then 2 squared plus 10. So we have division, exponents, and addition. Looking at PEMDAS, there's no parentheses, but we do have an exponent, the E, so we need to do that next. 4 divided by 2 squared, our exponent, gives us 4, and then plus 10. Now we just have division and addition. Division comes first, D before the A. 4 divided by 4 is 1, plus the 10, and we get 11. Very different than our original 20. Let's look at a different example. Say we have 6. This time we're going to have an open bracket. 52 minus parentheses 3 plus 4 close parentheses squared, and then close the bracket. If you're not sure how the bracket comes into play, think of the bracket as an extra set of parentheses, which essentially it is, but we use the bracket to differentiate from the parentheses so we can keep track of everything. So since we technically have two sets of parentheses, how do we take care of the parentheses here? Well, we want to work our way from the innermost parentheses to the outermost. So the bracket came first, which means that this parentheses inside is the most interior portion. So we need to take care of this first. So the 6 stays, we have times the 52 minus parentheses first, 3 plus 4, that gives us 7. I'll leave it in parentheses, squared, close bracket. So we took care of the most interior parentheses, and now notice that we have inside the outer parentheses subtraction as well as an exponent. Looking at PEMDAS, we know exponent is going to come first. So we'll have the 6 times 52 minus 7 squared, which is 49. And at this point, we basically just have one parentheses here, even though it's still a bracket. That leaves us with 6 times 52 minus 49 is 3. Now we have 6 times 3, and that gives us a final result of 18. Now what would happen if you have a problem that's written out like a fraction? For example, let's say we had 3 cubed minus 2 over 3 plus 2. So we should be familiar with the fraction line. That really represents division. However, when it's written this way, we need to take care of what's in the numerator separate from what's in the denominator, and then we can divide everything. In other words, this is kind of the equivalent to putting these in parentheses, 3 cubed minus 2, then divided by what's in the parentheses on the bottom, 3 plus 2. That way we know we have to take care of just the numerator and just the denominator before we can go ahead and divide. So let's start with the numerator, 3 cubed minus 2. So we have an exponent and subtraction. Exponent comes first. 3 to the third power is 27, then minus 2, and that will give us just 25. For the denominator, we have simply 3 plus 2, and we know that just equals 5. And so now we have the numerator and the denominator, which would be 25 over 5, which equals 5. Let's look at one final example, combining everything we've covered today. So let's say we have 8 squared minus 2/3 parentheses 5 times 15 minus 15 over 2 times 4 times 3 squared divided by 12. And then we're going to subtract another fraction from this. Over here we have 30 minus parentheses 3 squared plus 13 over 5 times 3 times 2 squared divided by 30. While this does look really complicated, I promise it's very simple when we follow PEMDAS. Like we saw a moment ago, anytime we have these written as a fraction, we want to take care of one side of the fraction and then the other. So let's start with the first numerator. We do have parentheses, so we want to take care of this first. So we have the 8 squared minus 2/3 times 5 times 15 is 75 minus 15. We still have parentheses, so 75 minus 15 should be our next move. 8 squared minus 2/3 times 75 minus 15 is 60. At this point, I'm going to go ahead and use the exponent, which you could have done earlier, but I do suggest doing one step at a time. 8 squared is 64 minus, and then we have 2/3 times 60, which is 40. And therefore, the first numerator comes out to 24. Now let's do the first denominator here. We have a parentheses and multiple things inside, and now we know exponents come first. So we'll have 2 times 4 times the exponent, 3 squared is 9, divided by 12. The 2 stays out here. We have multiplication and division. We'll just go left to right. 4 times 9 is 36. And then we have divided by 12. So now we have 2 times 36 divided by 12 is 3, and that gives us 6. So the first fraction is 24 over 6, which of course equals 4. So we'll keep that in mind for now. Let's now move to the second fraction. So the numerator, we have 30 minus, in the parentheses, the exponent will come first. So 3 squared is 9 plus 13. We have 30 minus, we need to do parentheses. 9 plus 13 is 22, which gives us 8. So that's the numerator for the second fraction. Now we need the denominator. We have 5 times 3 times the 2 squared. We'll do that first. That's 4 divided by 30. We have more to do in the parentheses, so let's do that. 5 times 3 times 4 is 12 divided by 30. And now we have multiplication and division left over, so we'll just go left to right. 5 times 12 is 60 divided by 30 equals 2. And that's our second denominator, which means this fraction is 8 over 2, and that equals 4. So now we can replace both fractions. The first fraction turned out to be 4, and so was the second. So we have 4 and then minus 4, and after all that, our final result is 0. Thanks for watching. If you found this video helpful, please smash that like button and subscribe for more videos.